Imagine waking up one day and realizing that Earth, our home since always, is just a chapter of our story, not the final destination. Sounds dramatic? Then consider the cosmic clock. The sun will die one day. Before that, supervolcanoes could darken the sky for years. Asteroids could slip into the wrong orbit. Solar storms could fry our infrastructure, and we ourselves could push the climate past points of no return. Staying tied to a single world is like living forever in a house built on the edge of a cliff. It works until the day it doesn't. The question that haunts us isn't if Earth will change, it's when. And when it does, will we be ready to live beyond it? Life can exist in space, but can humanity? Not as an idea, but as a real society, with children, schools, friends, fights, funerals, and celebrations. Is it possible to turn the emptiness between the stars into an address? Science already gives us clues. On Earth, there are microbes that withstand crushing pressures in the deep ocean, extreme acidity in hot springs, and doses of radiation that would be fatal to humans. Some survive years of freezing. Others enter suspended animation and wake up when conditions improve. In the lab, we've seen bacteria endure even a vacuum for short periods when shielded by dust. And there's the panspermia hypothesis. Rock fragments blasted out by impacts might carry simple life from one planet to another. Inside asteroids, rock could act as a radiation shield and help keep temperatures more stable. That means organisms might cross space inside natural capsules. If life in its most stubborn form can do it, why can't we? Because we're complicated. Humans don't survive on water and energy alone. We need complete ecosystems, breathable air, safely recycled water, varied foods to avoid deficiencies, enough gravity to keep muscles and bones strong, and a magnetic field or shielding capable of blocking radiation. We also need what few spreadsheets include: windows, landscapes, sun on our faces, a sense of outside, a place to walk without a helmet. Human nature is as psychological as it is biological. Even so, planners and scientists have imagined bold solutions. One is the World Ship, or Space Ark, a gigantic habitat, kilometers long, designed to sustain tens or hundreds of thousands of people for generations. Instead of going and coming back, the idea is to live on the ship. For gravity, it would rotate slowly, creating centrifugal force along an inner cylinder lined with farms, shallow lakes, and arched neighborhoods. If you looked up at the sky of this cylinder, you'd see another city on the opposite side, upside down. And yet everything would be in balance. Energy? Abundant if we stay in the solar system. Vast collectors turning sunlight into electricity. Water? Recycled indefinitely, as we already do on space stations, but at a much larger scale. Air? Produced and filtered by internal forests and life support systems. Basic arithmetic suggests it's possible. But here's where math meets reality. Keeping all of that running year after year, century after century, is the real challenge. And to complicate things, there's the vastness of space. A vastness not conquered by willpower, but by time no single generation wants to pay in full. If you've decided in your head that the solution is to go to another star, a new question appears. With what vehicle and how long would it take? Even if we reached high fractions of the speed of light, collisions with interstellar dust would become high-energy hazards. Giant ships would need thick shielding, extreme redundancy, stockpiles of raw materials, and an entire civilization on board able to fix everything that breaks. Because things will break, and even then, the trip would take centuries. Whoever boards knows they aren't going to another world. They're founding a new world inside the hull. So, can humanity live in space? Technically, yes, but technical isn't the same as viable on human timescales. The question starts shifting from whether we can to how we would, and that's where we face the hardest decisions we may ever have to make. If the goal is to remain in space, there are two paths: adapt the environment to us, or adapt ourselves to the environment. The first is more intuitive: build habitats that mimic Earth. The second is unsettling but perhaps inevitable: modify bodies, minds, and cultures to handle what engineering can't get around. Habitat first. Picture an O'Neill cylinder, 2 or 3 twin cylinders connected, spinning to generate something like 1G. Each would have agricultural zones, forests, and artificial lakes, a controlled water cycle, treatment stations, mosaic biomes to maintain ecological diversity and complete diets, and a calendar of simulated seasons adjusting lighting and humidity. It's not a space station, it's a pressurized hollow continent. Far from the sun? Swap solar panels for long-lived nuclear reactors and an internal supply chain based on asteroid mining. Each rock brings metals, silicon, ice. Logistics become mining plus manufacturing plus recycling. The most valuable currency stops being gold and becomes low entropy. Systems in order, available energy, and reusable materials. Now, the caveats. Radiation. In deep space, solar protons and high-energy cosmic rays slice through DNA like hail through a fragile roof. Shielding is possible. Water, polyethylene, rock layers, artificial magnetic fields. But it costs mass, and mass is expensive to accelerate and maneuver. Microgravity. Without enough rotation, the human body wastes away. With too much rotation, nausea and Coriolis effects get in the way. Ecology. Keeping a closed ecosystem stable for centuries is a science we're only beginning to learn. Small imbalances can turn into silent collapses. It's the math of life. 1,000 variables in constant feedback. Then comes the human factor. A space ark isn't just a ship. It's a city with politics, justice, inequality, art, crime, religion, humor. How do you prevent internal disputes from destroying a project that must last generations? How do you sustain rare technical vocations, surgeons, reactor engineers, closed-system ecologists, when the culture might lean toward other careers? Mandatory curricula? Incentives? Artificial intelligences as living libraries of maintenance? And what about emotional bandwidth? Where do people unload frustrations without wrecking the things that keep everyone alive? Collective psychology becomes part of life support. Perhaps that's why some argue for the alternate path. Adapt humanity to space. Genetic modifications to tolerate more radiation, improve metabolism on more restricted diets, and withstand varying gravity. Cybernetic implants to monitor homeostasis and correct microdefects before they become diseases. Even the most radical idea, migrating the mind to artificial substrates, a form of digital consciousness where long journeys stop being a biological obstacle. This is where the question changes tone. Humanity can live in space, but will it still be humanity? While we argue about that, there's a middle ground that could be the first concrete step. Living at large scale within our own solar system. We don't have to leap to Proxima Centauri to decouple our survival from Earth. We can build habitats in high Earth orbit, at Lagrange points, around the Moon, in solar orbits where light is stable and asteroid mining is only months away. A network of O'Neill cylinders could form inhabited belts, linked by regular cargo routes and human transport. Think of it as an archipelago, each island self-sufficient enough, but trading resources and knowledge with the others. And where do asteroids fit in? Beyond providing materials, they're potential homes. Lined interior caverns with water from the asteroid itself converted into radiation shielding could become mining and research habitats. It's not as poetic as a green valley inside a cylinder, but it's practical. Less shielding mass to haul, less exposure, more raw material right inside. Many of these habitats would be temporary, like construction sites, while world ships scale up. Even in this more local scenario, the cosmic vastness reminds us we won't defeat space. We'll coexist with it. What changes is the math. Many homes in different orbits are more resilient than a single home under the same clouds. Humanity stops being a single point of failure. We've reached the final dilemma. Who do we want to be when we live beyond Earth? If we adopt space arcs, we'll live in cities that never land. Children will be born and die under a sky that's a curved ceiling painted by LEDs. There will be tales of a blue planet that great-grandparents vaguely remember, like legends of an ancient garden. Simulated rain festivals with programmed drizzles and the smell of artificial ozone will be calendar luxuries. The windows will show real stars, but the wind will be controlled by software. It's a possible world, but is it the world we want? Maybe. To preserve who we are, we'll need rituals to replace what nature once gave us for free. Hikes in internal forests, outdoor schools with 1G gravity, sports invented for the cylinder's rotation, moon parks with 0.16G. In an arc, culture isn't entertainment, it's engineering for mental stability. We'll also have to decide how much risk we accept. A society in space must be obsessed with redundancy, duplicate everything, triple what cannot fail, train everyone for emergencies, set clear lines of authority in crises, and at the same time avoid authoritarianism. A tightrope that's hard enough on Earth. In space, it's survival. To succeed, we may need what we currently call nitpicking, inspections, checklists, simulations, a culture that values people who find flaws before they become headlines. And even then, there are no guarantees. Vastness doesn't negotiate. One failure could end an entire cylinder. A rare event could overwhelm any plan. Our consolation and our best strategy is plurality. Many arcs, many habitats, many forms of human life, scattered like seeds on the solar wind. If one falls, the others carry on. Humanity stops being a single statue and becomes a living mosaic. At this point, the question, can humanity live in space, gets a two-layered answer. We can, because physics doesn't forbid it, and engineering can already glimpse the path. Shielding, rotation, closed ecosystems, abundant energy, asteroid mining, maintenance networks, support AIs. We should, because depending forever on a single planet is betting on luck against statistics that will, one day, come due. But the most important layer is the third. Who will we be in the process? If we embrace world ships, we accept that home is something we carry with us. That the sky can be a ceiling. That the sunrise can be a dimmer, ramping up brightness over 20 minutes. Does that diminish us or make us more resilient? Maybe the answer lies in how we tell the story. Not as we fled Earth, but as we grew beyond it. Not because we hated our planet, but because we loved it enough not to stake everything on it. Earth will always be our origin, and hopefully, one of our homes. But the species we've learned to be, curious, inventive, stubborn, may have more chapters than a single world allows us to write. In the end, vastness doesn't need to be conquered. It needs to be navigated. And to navigate is to accept that you don't control the ocean. You just learn to use the wind. A space arc is exactly that. A sail raised against the void, guided by hands that still tremble, yet refuse to let go of the helm. If you made it this far, tell me, would you live on a world ship? Would you leave Earth's surface to live in a spinning cylinder in the dark with artificial forests and recycled water lakes? Or would you rather risk everything on a single planet? Drop a comment below. And if this reflection moved you, subscribe to the channel and turn on notifications. Share it with your friends who love space too. Thank you for watching, and see you in the next video.